Okay, so last time I forgot to discuss one 5 marks question from PhD, the PhD question TIFR, this TIFR. So this is the ninth question of TIFR 2025. So the problem is a random walk problem. Pro- this is saying that a particle P moving in one-dimensional discrete lattice with lattice constant A, and moving forward is the probability P, and moving backward is probability Q, that is 1 minus P, and you have to calculate this quantity. Okay, so first pause the video and give the problem a try, and then look at the solution. Okay, so yeah, so what is, suppose it moves a distance x, and it has n1 forward steps and n2 backward steps. Okay, so the distance x its travel is n1a minus n2a. Okay, so a into n1 minus n2. So what is x bar? X bar is a into n1 bar minus n2 bar. Okay, so x bar means average of x. Okay, so average, this is average. So what is the average of a quantity n1? It is simply n into the probability p minus, moving backward, the probability is q. Okay, so a n into p minus q. Okay, so now what is x square? So x square is simply a into average of n1 square plus n2 square minus 2 n1 n2. Okay, now what is the average of n1 square? Okay, so average of n1 square is average of n1 whole square plus delta n1 whole square. Okay, so we know from binomial distributions. Okay, so the we know from binomial distribution that average of x square minus average of x whole square is equal to delta x whole square. Okay, so this is called, we call the variation. This is called the variation or sigma square. Okay, so what is n square, n1 square? It is simply n square p square plus what is delta n square? It is npq. Okay, so this is n1 square. Now what is average of n2 square? It is similarly n square q square plus npq. Okay, now what is the average of n1 on n2? So it is simply average of n1 into n minus n1. Okay, so average of n1 into n minus average of n1 square. Okay, so you now have the average of x square is a square into average of n1 square plus average of n2 square minus 2 into average of n1 n2. Okay, so a square into n2 square minus 2 into average of n1 n minus average of n1 square. Okay, so I am using this 2 to 2 n1 square, and there is a n1 square, so I am writing like this. Okay, so it is n a square into n square q square plus npq minus 2 into n, average of n1 is np, so n square p minus average of n square, so n square p square minus npq. Okay, so yeah, I think there will be a better way. Okay, so let's write it as n1 into n is n square p minus n square p square minus npq. Okay, and this will be 2 into n square p, take n square p common from the first two terms, minus npq is equal to 2 into n square pq minus npq. Okay, so let us use this expression. Okay, so average of x square is equal to a square into average of n1 square is n square p square plus npq. Okay, plus average of n2 square is n square q square plus npq and minus average of 2 n1 n2, that is 2 into n square pq. We have calculated n square pq minus npq, minus npq. Okay, so it is n square into s square into n square into, take n square common, you will get p minus q whole square, plus there is npq here, npq here, there is 2 npq here, so 4 npq. Okay, so if you calculate the quantity x square minus x bar square, so what is x bar? X bar you already calculated this quantity, so if you subtract this from this, you will get 4 square into npq. Okay, so this will be the answer. And for this problem, I have done it wrongly last time. I was in a hurry and done wrongly. One of my friend pointed out, so thanks to him. So look at carefully. There is two pole. Okay, k plus I into k minus I. Okay. So now you can choose either this contour rotating anti-clockwise. Okay, so it is minus infinity to plus infinity. Okay, and it is I infinity. Here the radius is infinity, so it is plus I infinity. Okay, so this is I, and you can choose the contour in clockwise direction in the lower half plane. Okay, here it is minus I infinity, and the contour is minus I here. Contour, sorry, pole. Now look at the function e to the power minus I kx. What happened to x tends to I infinity? At x tends to I infinity, the function has e to the power I into infinity. Okay, so I square minus 1 minus minus plus, so e to the power k infinity, so it is diverging. Okay, diverge, and x tends to minus I infinity. Okay, what happened to this function? It is minus ik into minus I infinity, that is e to the power minus k infinity. Okay, that is converge. So you can't choose this contour, you have to choose this contour. Okay, because here the contour has to go with the point plus I infinity, and at plus I infinity it is diverging. Okay, but if it go with minus I infinity, okay, with radius minus I infinity, it is converging, so you have to choose this contour. Okay, so last time I did this mistake, I don't look very carefully, but this is the right way. So now you can see that now you are in the lower plane and rotating clockwise, so the value of the integral itself take a minus sign, and the residue is minus I into minus I into e to the power minus I x into value of k is minus I. Okay, so it is pi e to the power minus x. Okay, so yeah, so that's why for these two reasons you can't choose this contour. Okay, for these reasons you can't choose this contour, you have to choose this contour. Okay, so yeah, thank you, and I will next do the part A.